It is 4:47 in the morning. Most of the human workforce is still asleep, but on the floor, the machines are already moving. A robot reaches down, picks up a heavy auto part, and places it with millimeter precision. We are no longer looking at supervised lab prototypes. These humanoid machines are now completing 30-hour continuous shifts, moving 40-pound components for days at a time without a single human break. This view of the BMW Spartanburg facility shows robots fully integrated into the production line. In this specific pilot, humanoid robots handled 90,000 individual parts over 1,250 hours of active operational time. For a decade, experts insisted industrial deployment was a 2030 problem. In the last year, leading firms revised that to 2028. But with the deployment at BMW and other major plants, the timeline has effectively collapsed into the present. This creates a new dynamic on the floor. For the first time, human beings are sharing the physical workspace with independent decision-making machines. In 2026, the autonomous coworker moved from an engineering ambition to a permanent presence in the physical workspace. This is the great rupture. To reach this point, the physical hardware had to match human capability. Boston Dynamics just shipped their all-electric commercial Atlas. It has 56 degrees of freedom, allowing its limbs to articulate with human-like range, and it is already heading to Google DeepMind's facilities for active duty. But factories are highly controlled. The real test is chaos. Right now, humanoid machines are navigating the floor of Haneda Airport in Japan, maneuvering through corridors designed for pedestrians and luggage carts. The reason these machines look like us comes down to simple economics. We built our civilization, our stairs, counters, and narrow corridors to fit human bodies. A conventional conveyor belt can only move an object in a straight line, and a single-purpose robot is limited by its fixed base. A machine with 2 arms and 2 legs can navigate the architecture we already have, performing multiple tasks without requiring a complete infrastructure overhaul. Mastering movement in these human-shaped environments was the mandatory first step. The machines had to learn how to safely occupy our physical space before any advanced collaboration could begin. Behind every one of these physical machines is a hidden layer of software making that movement possible. NVIDIA is acting as the digital infrastructure for the entire industry with their Isaac development platform. Instead of practicing in the real world, developers generate synthetic data. This allows robots to run through millions of virtual scenarios, making mistakes and learning corrections long before they ever touch physical plastic or steel. And they're doing this inside NVIDIA's Newton 1.0 physics engine. This software calculates hyper-accurate collision detection and simulates how flexible materials react when grabbed, ensuring the digital practice matches physical reality. Because of this hyper-accelerated digital training ground, a robot can walk into a crowded room and operate safely on its very first day. While NVIDIA builds the training ground, the intelligence layer shifted this May when Meta acquired the robotics AI startup Airy. Historically, engineers programmed robot movements with strict code. Meta is moving toward a different paradigm, training models that learn directly through physical interaction with messy, real-world human environments. Meta holds more behavioral data on human movement and social patterns than any other company. They are now taking that engine of human understanding and pointing it at physical robots to teach them our habits and expectations. Their goal is to build the software layer that other manufacturers license, effectively creating a platform for physical labor where robots can be programmed for millions of specific tasks. This shift has caused major financial institutions to scramble. Goldman Sachs revised their forecasts 6 times in 3 years, now projecting the humanoid market could reach $38 billion by 2035. The Meta acquisition gave these machines the ability to predict and adapt to human behavior, adding collaborative intelligence to their existing physical muscle. For the people working alongside these machines today, the dynamic is augmentation. The robots are absorbing the dangerous, repetitive, and physically destructive tasks, while human workers focus on judgment and interpersonal problem-solving. This workforce is also becoming more accessible. Companies like Unitree are pushing out utilitarian machines on subscription models, lowering the barrier to entry so that humanoids can move beyond enterprise factories and into broader consumer use. However, this scale depends on a supply chain where China produces the vast majority of critical actuators, sensors, and motors. These are the physical guts of the machines, And relying on a single geographic source creates a significant strategic bottleneck for Western manufacturing. Without universal safety standards or a secure supply chain for these parts, the rapid deployment of an autonomous global workforce introduces new vulnerabilities into our industrial infrastructure. The fundamental definition of labor has been altered. We are no longer just toolmakers. We are the architects of a new class of physical coworkers. What emerges next is an integrated ecosystem where humans and machines walk forward together into the physical workspace.